Today's tech talk is about authentication method for your web and mobile applications. So this is today's agenda. In this tech talk, I will explain about authentication and authorization and why authentication is important. After that, I will explain about some authentication methods, and at the end, I will explain some authentication methods for mobile apps. So in the first topic, authentication versus authorization. So authentication is the process of verify the credentials of a user or a device attempting to access a restricted system. Meanwhile, authorization is the process of verify whether the user or a device is allowed to perform certain tasks on the given system. If I explain it in simply, authentication means who are you and authorization means what can you do. Furthermore, authentication comes before authorization. That is, a user must be valid before they are granted access to resources based on their authorization level. The most common way of authenticating a user is via username and password. Once authenticated, different roles such as admin and moderator are assigned to them, which grant them special privileges to the system. When it comes to the stateless architecture or service-oriented architecture, we got a lot of new concepts and technologies in the market. In this tech talk, you will learn how to handle authentication on RESTful APIs. Before going through the authentication method, let's identify why user authentication is important. User authentication is a method that keeps unauthorized users from accessing sensitive information. For example, user A only has access to relevant information and cannot see the sensitive information of user B. Cyber criminals can gain access to a system and steal information when user authentication is not secure. The data breaches companies like Adobe and Yahoo Face are examples of what happens when organizations fail to secure their user authentication. So in this slide, I have listed some authentication methods. So let's dive through them. First method is cookie-based authentication. Cookie authentication uses HTTP cookies to authenticate client requests and maintain session information. It works as follows. The client sends a login request to the server. On the successful login, the server response includes the set cookie header that contains the cookie name, value, and expire time and some other information. The client needs to send this cookie in the cookie header in all subsequent requests to the server. In this slide, we clearly display how this process happens. In this diagram, you can clearly see client posts the login credential to the server. Server verifies the credentials and creates session ID, which is stored in server and returned to client via set cookie on subsequent request. When in the logout, the session ID will be cleared from both client, cookie, and the server. So let's move on to the next method, that is token-based authentication. Token-based authentication is gaining in popularity because of the rising single-page application and statelessness of the application. There are different ways to implement token-based authentication. We will be focusing on most common use, JSON Web Token. On receiving the credential from client, the server validates the credentials and generates a signed JWT which contains the user information. The token will never get stored in server. On subsequent request, the token will be passed to server and gets verified in the server. The token can be maintained at client side in local storage, session storage, or even cookies. JWT consists three parts: header, payload, and signature. All three are base 64 encoded. Since they are encoded, anyone can decode and read the message, but only authenticated users can produce valid signed token. The token is authenticated using the signature, which is signed with a private key. From this diagram, you can understand how this token-based authentication is happen. In previous slide, I have mentioned we can store tokens in client side, in local storage, session storage, even in cookies. So let's talk about local storage and session storage. They are web storage objects. Web storage objects, local storage, storage and session storage allow to save key value pairs in the browser. So we already have cookies, then why we need additional objects? Unlike cookies, web storage objects are not sent to the server with each request. Because of that, we can store much more. Most modern browsers allow at least 5 megabytes of data and have settings to configure that. Also, unlike cookies, the server can't manipulate storage objects via HTTP headers. So let's find out advantages and disadvantages of token-based authentication. First, I will explain about advantages. It's stateless. The server doesn't need to store the token as it can be validated using the signature. This makes the request faster as the database lookup is not required. And token-based authentication are suited for microservices architecture, where multiple services require authentication. All we need to configure at each end is how to handle the token and token secret. Now let's talk about disadvantages. Depending on how the token is saved on the client, it can lead to XSS and CSRF attacks. And tokens cannot be deleted. They can only expire. This means that if the token gets leaked, an attacker can misuse it until expire. Thus, it's important to set token expiry to something very small like 15 minutes. Refresh tokens need to be set up automatically issue tokens at expiry the token. One way to delete token is to create a database for backlisting token. This adds extra overhead to the microservice architecture and introduces state. Let's discuss about another authentication method. One-time pass (OTP) are commonly used as confirmation for authentication. OTP are randomly generated code that can be used to verify if the user is who they claim to be. It's often used after user credentials are verified for apps that leverage two-factor authentication. To use OTP, a trusted system must be present. This trusted system could be a verified email or mobile number. Modern OTP are stateless. They can be verified using multiple methods. While there are few different types of OTPs, time-based OTP (TOTP) is arguably the most common type. Once generated, they expire after a period of time. Since you get an added layer of security, OTPs are recommended for apps that involve highly sensitive data like online banking and other financial services. Let's look at disadvantages and advantages of OTP. Advantages are it adds an extra layer of protection. And when using OTPs, no danger that a stolen password can be used for multiple sites or services that also implement OTP. Discuss about disadvantages. You need to store the seed used for generating OTP. And OTP agents like Google Authenticator are difficult to set up again if you lost the recovery code. And the last one is problems arise when the trusted device is not available, such as dead battery, network errors. Because of this, a backup device is typically required, which adds an additional attack vector. So let's talk about third-party authentication method or OAuth and OpenID. And OpenID are popular forms of authorization and authentication respectively. They are used to implement social login, which is a form of single sign-on using existing information from a social networking services such as Facebook, Twitter, or Google to sign into a third-party website instead of creating a new login account, especially for that website. This type of authentication and authorization can be used when you need to have highly secure authentication. Some of these providers have more than enough resources to invest in the authentication itself. Leveraging such battle-tested authentication system can ultimately make your application more secure. So, if I talk about this OAuth, at its core, OAuth provides clients secure access to a server's resources on behalf of a resource owner. OAuth allows access token to be issued to third-party clients by an authorization server with the approval of a resource owner. The third party can then use the token to access protected resources hosted by the resource server. As I explained about OpenID, OpenID is a protocol that enables website or application application to grant access to users by authenticating them through another service or provider. OpenID allows you to use login credentials from the OpenID provider, such as Google, to log into another application like Facebook. For example, if you want to access www.example.com, they can ask you for your OpenID in the form of Google or Facebook account. If you enter your OpenID, example.com will redirect you to your OpenID provider and you will authenticate yourself, confirming your identity, and then we allow access to your account on example.com. So let's talk about advantages and disadvantages. If I talk about advantages of third-party authentication method, it improves security and easier and faster login flows since there are no need to create and remember a username and password. And third one is, in case of a security breach, no third-party damage will occur as the authentication is passwordless. And we talk about disadvantages. Your application now depends on another app outside of your control. If the OpenID system is down, users won't be able to log in. And people often tend to ignore the permission requested by your own application. And the third one is, users that don't have accounts on the OpenID providers that you have configured won't be able to access your application. The best approach is to implement both username and password and OpenID and let the user choose. So the last authentication method I have included in this talk is SAML. SAML stands for Security Assertion Markup Language. It is an XML-based open standard for transferring identity data between two parties, an identity provider and service provider. So what is identity provider? It performs authentication and passes the user's identity and authorization level to the service provider. So what is service provider? It means trust the identity provider and authorizes the given user to access the requested resources. So if I explain more about SAML, the technology industry created SAML to simplify the authentication process where users need to access multiple independent web applications across domains. Prior to SAML, single sign-on was achievable but relied on cookies that were only viable within the same domain. It achieves this objective by centralizing user authentication with the identity provider. Web application can then leverage SAML via the identity provider to grant access to their users. This SAML authentication approach means users do not need to remember multiple usernames and passwords. It also benefits service providers as it increases security of their own platform primarily by avoiding the need to store password and not having to address forgotten password issues. So this is the end of the methods of authentication methods. So now let's look at why web app security is different from mobile app. There are some points. The first one is, mobile app can collect much more information about users such as location, biometric, video than web browser. Web app never release their code publicly, but anyone can download mobile app from the public app stores and inspect the code using open source tools. This makes finding flaws in mobile app easier. The third most critical difference between mobile app and web app is where the apps run. Mobile app code runs on poorly protected end-user devices where the users are the admins. They may have lacked standard around applying update or being selective in the app they choose to download. In previous slide, I have mentioned stateless but stateless. So in order to clearly know about mobile app authentication, we have to know the difference between stateful and stateless authentication. So you will usually find out the mobile app uses HTTP as the transport layer. The HTTP protocol itself is stateless. So there must be a way to associate the user's subsequent HTTP request with that user. Otherwise, the user's login credential would have to be synced with every request. Also, both the server and client need to keep track of users. This can be done in two different ways, with stateful authentication and stateless authentication. Stateful authentication. A unique session ID is generated when the user logs in. In subsequent requests, this session ID serves as a reference to the user details stored on the server. Session ID doesn't contain any user details. date. With stateless authentication, all user identifier information is stored in a client-side token. The token can be passed to any server or microservice, eliminating the need to maintain session state on the server. And web applications commonly use stateful authentication with a random session ID that is stored in the client-side cookie. Although mobile apps sometimes use stateful sessions in a similar fashion, stateless token-based approaches are becoming popular for a variety of reasons. They improve scalability and performance by eliminating the need to store session state on the server. Tokens enable developers to decouple authentication from the app. Tokens can be generated by an authentication server and the authentication scheme can be changed seamlessly. And so, there are multiple authentication methods for mobile app. OTP password, token management, use biometric, and so on. So, in this tech talk, I will explain use biometrics. What is mobile biometric authentication? In simple terms, mobile biometric authentication is a form of authentication that uses biometrics to detect and authenticate the identity of the user trying to access a mobile app. It can be performed using multiple ways: fingerprint readers, facial recognition, voice recognition, and more. These biometric tools can either be an addition or a replacement for the traditional username password method. So, how is biometrics in mobile devices enabled? Most of the latest smartphones using Apple, Android, and Microsoft technologies are now fitted with advanced digital sensors such as touchscreen, cameras, fingerprint scanners, and microphones that are facilitating user authentication. So, why is mobile biometric authentication gaining widespread popularity? Here are the reasons. Biometrics allow devices to use your physical attribute, fingerprint, face, voice, to authenticate your identity. This adds to your overall online experience in place of passwords that are hard to remember. Biometrics can also be used as part of the multi-factor authentication process, especially when signing into sensitive or confidential accounts. So, this is the end of today's tech talk. Thank you for your participation.